look what 3 did. Look what 10 does. If you can see, the function, the red is our parent function. Blue, it kind of got squished, right? So we describe this transformation as a vertical translation, like mathematicians in math. So this is considered a vertical translation. I'll answer your question later. So a vertical translation is when it kind of goes like this. It gets stretched vertically, so it kind of gets a little skinnier. And that's when A is 10. Remember, when A was bigger than 1. Well, it also said when A is negative, something happens. Because when it's less than 0, it's negative, right? So let's say if A is negative 2. Let's just do negative for now. What did a negative value of A do? This is called a reflection. See how it's reflected? Imagine there's like water or a mirror here on the x-axis, and you see the reflection in the mirror. So yeah, so a negative value of A creates a reflection. So that's the reflection. What if I add a negative value but negative 5? Well, the negative value always makes a reflection. The 5 shrinks or vertically stretches the graph. So remember, whether the number is negative or positive doesn't matter. If the number is bigger than 1, essentially, you get a vertical stretch. Okay, well, how do I get a compression? Because remember, there was a note about compression. Well, what number, what value does A have to be? Can someone give me an example of an A value that will cause a vertical compression in the chat, please? Multiple people, I don't even care. Multiple answers, there's like infinite number of answers here. So anyone? For A, what value of A will cause a vertical compression? And this is from grade 10 as well, in case you're wondering. So it's not something new right now. No one wants to answer, Mr. Khan. Or is everyone asleep? 0? Close. So 0 is between negative 1 and 1. And let's see what happens if we put in 0 here for my A value. If you can't see it, it's this flat line here. When you multiply anything by 0, it basically just kills the whole thing. So yeah, so it's not going to be 0. But good guess. Good guess. Because 0 was a value between those two. Give me another number that's between negative 1 and 1. Or are you saying that there's absolutely no numbers between negative 1 and 1? Like they don't exist? Perfect. Someone got it. 0.5. And as I mentioned, there's an infinite amount of values between 1 and negative 1. And they're all the decimal and fractional values. So 0.5, see how the graph gets a little fatter? Let's say if I do 0.05. There, it's super fat now. So it's wide. So we consider this a vertical compression because it's being squished from the top down. And why? And when it's being vertically squished, it's being horizontally expanded. So this is considered a vertical compression. So just understand that my A value can vertical stretch, compress, or reflect. So we went over now both our A and C values, and both of these transformation values affect your Y coordinates. We're going to do an example of that soon. Here we have our transformation values that affect the X coordinates. We have a horizontal translation, our D value. Just like our C value, this will move the graph instead of up and down, though, left or right. So there's a typo here. This is meant to be D. So when D is bigger than 0, the graph shifts right. When D is less than 0, the graph shifts left. And when D is 0, there is no shift. This is very simple. So let's see, how does that look like? Well, look at the function here. The key thing that you can see to let you know, the hint or clue, is that if there are brackets, then there most likely is a D value if that value is being added or subtracted. So if you have a value that's being added or subtracted to X within brackets, that is going to be your D value. So how does that look like here? Well, let's see. First, you gotta have brackets. and you gotta have a value that's being added or subtracted. So here I did plus 5. Now look what plus 5 did. Plus 5 moved the graph left or right. Answer in the chat quickly. Left or right? When I have the equation y equals x plus 5 squared, the graph compared to the red graph, which is the original function, the blue graph, did it move to the left or did it move to the right? Left. Exactly. Perfect. Thank you. The blue graph has moved to the left. Now, hold on. It says if d is bigger than 0, the graph shifts to the right. What gives? Because isn't d plus 5 here? The answer is your d value is the opposite sign of what's written in the equation. That's important. A lot of students make a mistake here. So this is the most common mistake that I've seen students make when it comes to d value. They think the d value is just a number there. That's incorrect. Your d value is the opposite sign of that number. So my d value in this case is actually -5. So since d is -5, the graph shifts to the left. And what if I switched it up and made it x minus 5? And here in this case, the graph shifts to the right. And my d value, is it -5? No, my d value is not -5. It's +5, because remember, my d value is the opposite sign of the number within those brackets. So just be very careful with that. That's the only trick when it comes to d value. Otherwise, it's pretty straightforward, left or right, by the amount, by the number amount. K is the most difficult transformation value I've noticed when it comes for students to describe and comprehend. So just like A, there's 3 different sections. There is a horizontal compression, a horizontal stretch, and then a horizontal reflection. We're going to do the horizontal reflection first because that's super easy. And K, if you can see within the equation, is also within brackets. It's important. So if you see brackets and a number inside those brackets, it can either be your K value or your D value. It depends on what that number is doing. If it's being added or subtracted, it's your D value. If it's being multiplied, or I guess divided, but division and multiplication are the same thing. If it's being multiplied, then it is your K value. So if I were to show my K value here within this equation, remember it needs to be multiplied with x, so it's going to be something like 6x. So I did 6x. So it kind of made the graph skinny, just like your A value, right? And that's technically what it does. It does the exact same thing as the A value, except instead of affecting the Y values, it affects the X values. And when we do an in-depth example, you'll understand what I mean by that. So this is a horizontal stretch or compression. What do you guys think? Is this being horizontally stretched, or is it being horizontally compressed? I want an answer. Just one word. Either you write stretch or you write compress. You tell me. Someone thinks it's being horizontally compressed. 2 people. But doesn't it look like it's getting skinny? What do you guys think? All right, a few people. I'm just going to wait 1 minute. So, bunch of mixed opinions. Some people say stretch, some people say compressed. So if you take a look at this graph and think about it, put your hand to the left of the red graph. Put one hand to the left, put one hand to the right. And now, if I were to take my hands and squeeze them together, would I make the blue graph? So if I take my hand to the screen and I put my hand, my left hand on the left side of the red graph, I take my right hand and put my right hand to the right side of the red graph, and I have the 2 sides, and am I squeezing in